In this video, we are going to talk about the testing strategy and the test cases for SCD2 implementation. Before we dig deep into that, let's understand what is SCD2. So SCD2 basically allows us to maintain all historical and current data of a dimension. Whenever the source sends a new record, it is inserted in the dimension table, while if an existing record is updated in source, the old record is updated and is marked inactive and a new record is inserted in the table. Let's see this with an example. So we are loading our target table for the first time here and the source has two records. Since they do not exist in target, both of them will be inserted. If you notice closely, the SCD2 or target table has four additional columns. The surrogate key EID_S, which is a sequence number and is updated by 1 every time a new record is inserted. The start date and end date, which signifies the duration between which the record was active. Right now, these are the most recent active records, which is why we will set the last date to null and the flag suggesting if the record is currently active or not. Now here an existing record was updated. The designation and salary for Jane has changed. Earlier she was an associate with a salary of 60,000. Now she has become a senior developer with a salary of 70,000. So the previous record will be inactivated. The end date will be set as 1 day prior to when we got this update and the active flag will be set as N. Also, we will insert a new record in the table with start date as the date when we got the data and date as null because this is the most recent record for Jane and the flag will be active. Also, this surrogate key will increment by 1 because we inserted a new row. Notice the ID or natural key is still the same, just the surrogate key has increased. Also, this source has a new row for Paul that will also be inserted in our target table. So the idea of SCD2 is very simple. Maintain all history and current snapshot. You can identify current records with end date as null or active flag as Y. If it does not exist in target, then insert, and if it exists, then inactivate the old record and insert a new record. So an average QA person would test these three scenarios. If the record is new, is it getting inserted? If we receive an update, are we updating and inactivating the old record along with inserting a new one? And if we receive both of them, are we inserting all of them while we also update and inactivate the old ones? A person who is above average will also check that the surrogate key, the start date, end date, and flag are also updating correctly or not. But we have to go beyond average. So, what should we test in addition to these scenarios, and what should be our eventual goal while testing something? The goal is very simple: prevent the failure which may happen in production while ensuring the current code will work optimally in all scenarios. So let's talk about 20 plus additional scenarios that we should look for when we test SCD2 next time and how we can test them really quickly by creating a reusable test case template. So the very first thing we should look for is the structure of the new table. I have personally made mistakes while creating a table where I made a typo in a table name or a column name which went unnoticed and it looked really bad when users started using the tables. You should also focus on data types and data lengths to ensure your table structure has the capability to store data correctly from source. For example, if we have a data type as varchar 100 in source, but in our table we only have it as 50, then it will lead to truncation issues. The next common mistake that a lot of people make is by not creating a primary key on the surrogate key. This is a sequence number which should auto increment by 1 whenever a new row is inserted. So we should always create a primary or unique key on this. Also, if we intend to use it as a foreign key in our fact table and this does not have a constraint, it will not allow the foreign key to be created. So you should always highlight if a constraint is not created on the surrogate key. Also, as we noticed earlier, in this table, our natural key is employee ID. This column will be used often in our joins and filtering, so it is vital that we create an index on it because we are maintaining history. So we may have multiple records for each employee ID. So here a non-unique index should be created. If we do not create this index and we run a simple query to identify a particular employee ID, since the index is not available, Oracle will have no option but to do a full table scan, which can lead to performance issues. So any column that is potentially used for filtering should be considered for indexing. You can ask a question if you do not see any indexes on the table. Similarly, if the source table has any constraint, we should consider replicating them on the target table as well. Ideally, one may argue that we are getting refined data from the source itself, so why create a constraint? But it would ensure, in case if any manual updates are made, we do not insert or update any incorrect data. One very important thing is maintaining the audit columns in a table, which signifies when the row was inserted or last updated in the database. A lot of people may argue that we already have start date and end date in this table, which will serve the same purpose, but this will come in really handy if we are sending incremental, delta or change data to our downstream applications or reports. Also, if we have a huge number of updates for a day or every day, this column will help us track that easily. Let's move on to grants. I think this is almost never tested by QA teams because in a lot of applications, people log in from schema owners in lower environment which has all access. And because of this, a lot of time users and other applications are not able to view the tables because their user does not have the grant on these objects. So you should always make sure that the authorized users have the right grants on the objects. Also, you should look for elevated grants. For example, a reporting user should not be allowed to change the data or the structure of the table. Another important thing to note is the max value of surrogate key. What will happen when this value is reached in our table? Will we reset the counter? Do we foresee that the table will have a lot of data and this value can be reached in the lifespan of the application? If yes, we should consider changing the data type or ask what will happen when this scenario presents itself. Now let's move to the more vital scenarios, and you can test all of this with the black box testing where you do not have to understand the code. You just need to have your test data set up correctly and you should know how to trigger the job. Whenever you are testing the initial functionality, make sure you have very limited number of records and they cover the test scenario that you are looking to test. When you have a lot of records, it can be a little overwhelming initially to verify if the corresponding functionality is implemented correctly or not. So start with limited number of records. For example, here in order to test the new record functionality, start with couple of records and make sure that they are inserted properly. The start date, end date, flag and the surrogate key is populating correctly. The end date should be null and the flag should be Y. Now that you have tested the insert strategy, verify the update strategy, and this time also just update one of the record. Its corresponding record in target should be inactivated. The flag should be set as N. The end date should be updated with a date 1 day prior to when this action is happening, and you should have a new row with an incremented surrogate key. The end date should be null and the flag should be Y. Also verify the start date. If it is coming from the source, then great. Otherwise, this value should be the sys date. For the next test case, you want to club these scenarios together where you have both inserts and update in your data. so that you can ensure that both the functionalities together are working fine as well. For the next test, you want to verify what will happen if a record that is currently present in our table is deleted from the source. For example, here the record for John was deleted from the source table. What should happen in this case? Should we leave our target table as it is, or should we deactivate this record? This is a very common scenario which happens a lot of time, that the record is getting deleted from the source but is not getting inactivated in the target. You should always verify this scenario and confirm from the team that what exactly should happen in this particular case. Now once you have tested this with limited amount of data to capture scenarios clearly, you should load all the data from your source to your target, and you should do it multiple times to verify that the job is working as expected. If you have tested these 4 scenarios correctly, the basic functionality will work fine 99% of the times. In order to verify that in a little more detail, you should do a source versus target recon, where you should do a count comparison, and both systems should have exactly same number of natural key records. For example, in our case, we should have the same count of employee ID, and you should also do a data recon where you should compare the active records from your SCD2 table against the source table, and it should match perfectly. You should also check if you have any column that is completely null in your target table. There is a high chance that during the ETL job, the developer missed to connect that column to the target table. Now let's talk about this scenario. In case the source itself has duplicate records, what should be done in that case? Should we send a failure email to source stating that the data could not be loaded, or have we configured our job to pick the latest record from the duplicates based on a column value? This is a must test scenario and it leads to failures a lot of times. What about restartability? Let's say our job has failed because of any reason. Let's say the ETL tool, DB, or Unix operating system went down. What would happen in this case? Will a simple restart be sufficient? Do we require any manual cleanup? Simulate this scenario by deliberately failing a job in between. If a cleanup is required, you should log a defect stating that the job is not 100% restartable. What will happen in case if the job succeeds or fails? Will we get an email stating the same? In case if we have a failure, the email should clearly state which job has failed, in which environment, which team should be connected for the resolution, and what action needs to be taken. If this information is not readily available, you can ask the team to improvise on the content of the email. What will happen if the job runs for too long? What is an acceptable time limit for the data to be loaded? Let's say ideally the job should complete maximum in 15 minutes. What will happen if on a particular day it will continue to run for more than 1 hour? Will we get an alert stating that the job is taking more time? This long running session usually happens when we receive a huge file with large number of updates and inserts. Let's say the source is sending us a full file every day with 5 million records. The actual new records are 500, while for 1000 records, we have a change in the column value for an existing record. Ideally, out of the 5 million, we should only process these 1500 records, but a lot of time, developers simply check if the record is existing in DB and they try to update it without checking if something has actually changed. Verify this part because updates are very expensive and you will end up inserting a lot of data every day again and again. You should send a record from source which already exists in target and it has not changed. You should check if it was updated and a new record was inserted. If this is the case, then we have a problem. You should ask this question from developers if they are using MD5 or hash value to actually verify and update only the relevant changes. Similarly, a lot of times we notice huge amount of updates every day because a column value which is irrelevant keeps changing every day. For example, the source table is truncated and loaded every day, and they have a column load date signifying when the data was last loaded. Ideally, this is irrelevant for us, but if we have considered this column also in our SCD2, then we will have a huge number of inserts and updates every day which are not even required. Now there is also a possibility that we have an attribute from source which changes frequently, almost in every run. This can again lead to huge increase in our records every day, and this can make our dimension table huge in size. Such dimensions are also referred to as rapidly changing dimensions. Try to see if you have any such columns which change often. Should we ignore these changes, and should we not update our data in target when this attribute is changing? Or should we ask the development team if SCD2 is the best way to handle such dimensions? Can we consider normalizing them? If you want to learn more about this concept, you can watch my video on rapidly changing dimensions. Now let's move slightly towards the other table where this new table will be used. Have we created a foreign key on such tables? Are we going to index the foreign key? Are we going to use surrogate key or our composite natural key in our fact table? Have we taken care of these foreign keys and indexes? Also, are we planning to expose this dimension table directly to our consumers, or we are planning to create a view on top of it? Will we ever delete the data from this table, possibly purging or archiving inactivated data older than few years? What will happen to those keys in our child fact table? Will it get deleted as well, or will we set it to null? Now, this may sound a lot of scenarios for some people, but all of these can be tested in less than 1 day if you have your template ready. For common test scenarios, you should create templates in Excel with your test cases, and you should add new scenarios to those templates over a period of time, and then you should always reuse those templates. Another challenge a lot of people face is with test data generation to create scenarios. For that, I have created two separate videos using which you can create test data in Excel and SQL. I will drop a link to them as well. Hopefully, this video will help you improve your testing strategy for SCD2 and in general as well. If you have any questions, please drop in a comment, and if you have stayed till the end, please like the video and drop in a note. This will increase my motivation to make more such videos.